A more advanced problem that we might run into is to determine the intersection of a line and a circle. Now, if we think about it, the intersection of a line and a circle, there are three things that can happen. First thing that can happen is that there are 2 points of intersection. Next thing that can happen is that there are no points of intersection, so the line and the circle just don't intersect. Third thing that can happen is that the circle and the line intersect at a single point. We call this being tangent to the curve. That's a word that you're going to run into, especially if you go on and take some calculus. You're going to see lots of stuff involving tangent lines. But tangent means basically that it just comes up and touches it at that one point. So these are the three different situations. Now, we won't know in advance which situation we're in. What's going to matter is that when we go through the algebra will tell us what situation we're in. And we'll see that as we look at the examples. So here's our first example. Find the points of intersection between the line y equals x plus 1 and the circle centered at the origin with radius 3. Now, what is our overall strategy going to be? Well, the general strategy that we're going to have is that we need to have two equations, and we're going to try to substitute one into the other to solve for x and y. Now, in this case, we only start with one equation, the equation of the line, y equals x plus 1. We have a description of the circle, but we don't yet have the equation. So that's the first thing we need to do. Now, just as before, we need two pieces of information to get the equation of a circle. We need the center and the radius. And fortunately, we're told this explicitly. The center is at the origin, the point 0, 0, and the radius is 3. So we put this together into the formula for a circle. We get x, well, technically it's going to be x minus 0 squared, but since x minus 0 is just x, we're going to leave it like this. X squared plus y squared is equal to 3 squared, which is 9. And now we have this equation for our circle and this equation for our line. And we see that this is of the form y equals something, so we can take that y and substitute it into here. X squared plus, x plus 1 squared is equal to 9. Now we're going to need to do some algebra, so let's expand out the binomial, x squared plus 2x plus 1. And now we're going to move everything to one side of the equation and combine like terms. So we've got 2x squared plus 2x, subtract 9 from both sides. 1 minus 9 is negative 8, so minus 8 is equal to 0. And in this case, we could also divide this by 2. And we can see that we're left with a quadratic equation. Now we have to think, well, what are the methods we can use to solve quadratic equations? Well, one of them is factoring, another one is using the quadratic formula, or if you're feeling really fancy, you could try to do completing the square. Now in this case, when we look at this, we might quickly identify that factoring is probably not going to work, so that leaves us with either completing the square or the quadratic formula, and most students tend to go for the quadratic formula. Completing the square is useful and has its applications, but in this case, the quadratic formula is probably the easiest way to go. So here's our quadratic equation. X squared plus x minus 4 is equal to 0. Now we're going to use the quadratic formula, so we need to identify the a, the b, and the c in that formula. So ax squared plus bx plus c. So our a is 1, our b is 1, and our c is negative 4. Now everything is just a matter of execution. X equals negative b plus or minus the square root of b squared minus 4ac. All of this divided by 2a. b, okay, so b is 1. So negative 1 plus or minus the square root of b squared, which is 1, minus 4ac. So 4 times a is 4, and then times c is negative 16. So minus a negative is plus 16 over 2, which is negative 1 plus or minus the square root of 17 over 2. So this gives us our x coordinates. However, we are trying to find the points of intersection, which means we also need to find the y coordinates. Now we have a couple options. We could go to the circle formula and plug into that. It turns out to be super messy, but instead it makes much more sense to use this formula right here because it's already of the form y equals something. So y equals negative 1 plus or minus the square root of 17 over 2. There's our x plus 1. We have a little bit of fraction arithmetic to do here. Negative 1 plus or minus the square root of 17 over 2. We need to find a common denominator, so plus 2 over 2. And now that we have a common denominator, we can go ahead and do the arithmetic. I'm actually going to squeeze it in over here. So negative 2 plus 2 is plus 1. 1 plus or minus the square root of 17 over 2. Now at this point, a lot of students will just stop. but we haven't yet stated the points of intersection. We have some x values and some y values, but we need to pull it all together to get the points of intersection. So, what are our points of intersection? We'll take the plus case first. So -1 plus the square root of 17 over 2, 1 plus the square root of 17 over 2, and the other point when we take the minus case, so -1 minus the square root of 17 over 2, comma, 1 minus the square root of 17 over 2. And these are the 2 points of intersection. Notice how in this problem, the problem told us there would be 2 points of intersection. When we did the quadratic equation, we ended up with 2 separate values. This is what we mean by the algebra will tell us what's going on. And if we were to look at the picture, just sketch this real quick. Circle of radius 3, actually move to this side. Circle of radius 3, the line y equals x plus 1 goes up like this. So you can see that there's a point of intersection over here and another point of intersection over there. And so those are the 2 points of intersection. Here's another example. Find the x-intercept of the circle with radius 5 centered at the point 2, 5. Now in this case, when we look at the problem, we have no equations given to us. We have to work it all out. So let's first think about the picture. What are x-intercepts? X-intercepts are points along the x-axis that intersect the circle, or intersect whatever graph we're talking about. Now in this case, we have the circle of radius 5 centered at 2, 5. So here's 2, here's 5. So there's our center, and the radius is also 5. And so if we go down 5, we're going to go here, and that's going to be something like this. And of course, the top half of the circle as well. Now, what's interesting about this is we can see immediately where that point is, but we should also go through the process of solving it. The other thing is that we can see from the picture that it's going to be tangent, because if we're 5 away, 5 up from the x-axis and you have a circle of radius 5, it's just going to barely touch at that one point. And we'll see all of this come out of the equations. Now, the question is, well, what is the line? The line is this line right here. That's the line y equals 0. And so in this case, knowing that we're finding x-intercepts are the points that intersect with the curve intersects the line y equals 0. And so that's our first line. And now our second line, or second equation, is going to come from the circle. So I'm going to squeeze it up here. We have center, we have radius. The center is at the point 2, 5, and the radius is 5. And so therefore the equation is going to be x minus 2 squared plus y minus 5 squared is equal to 25. Let me make sure that's on the screen before I keep going. Okay, that fit. Perfect. So here's our formula. Now we're just going to plug things in. Y equals 0. We're just going to drop it right in. So x minus 2 squared plus 0 minus 5 squared is equal to 25. 0 minus 5 is -5. -5 squared is positive 25. So x minus 2 squared plus 25 is equal to 25. Subtract 25 from both sides. X minus 2 squared is equal to 0. Take the square root. X minus 2 is equal to, technically this is plus or minus the square root of 0, but since plus or minus the square root of 0 is the same thing, it's just 0. We just have one case. And this right here is where, once again, the algebra is telling us what's going on. The algebra tells us that there's only one point of intersection because we have plus or minus the square root of 0. If this were some other value, we might have 2 points of intersection. Or if this happened to be a negative value, it would be plus or minus the square root of a negative number. And then we'd say that there are no points of intersection because we're not going to deal with imaginary numbers when we're talking about intersections of curves on the line, on the plane. And so our x value is 2. We already have y equals 0 explicitly, so the intersection is 2, 0. So the x-intercepts of this circle are at this one point right here, 2, 0. And it's the only one.